All right, let's get right into it. When we talk about AI, we usually think about it analyzing data, right? But what if it could do something deeper? What if an AI could actually learn the structure of the data itself, learn how everything is connected, and then redraw its own map of reality as it goes? Well, today we're going to look at a model that does exactly that. So, first thing you have to get your head around is this. Most of the time, we kind of picture data as a nice, neat spreadsheet, rows and columns. But so much of the world's most valuable information just doesn't work that way. It's not a simple list. Think about it for a sec. Your social media isn't a list, it's a massive web of friendships and interactions. The atoms inside a molecule aren't just lined up, they're this complex 3D structure of bonds. This kind of data is what we call a graph, a network of points or nodes, and all the relationships between them. And to make sense of that, you need a whole different kind of tool. And that's where graph neural networks, or GNNs, come into the picture. These are a special class of AI that are literally built to navigate these complicated webs of information. They don't just look at the individual data points, the nodes. They're obsessed with the relationships, the edges that connect everything together. So GNNs are amazing at seeing these connections. But it turns out they've had this hidden weakness, a pretty fundamental problem that's been holding them back. And that weakness? We can call it the fixed map problem. Because for all their power, these AIs have basically been working with one hand tied behind their back. And hey, don't just take my word for it. The researchers behind this very paper put it perfectly. They said that the AI models we've been using rely on a fixed graph. This map of connections is just handed to the AI at the start, and it's basically forced to assume it's perfect. But the researchers started asking, what if that map isn't actually the best one for the job? This outdated map analogy really hits the nail on the head. So on the left, you've got your standard AI, a GCN. Imagine it's like a brilliant detective, but you've given it a torn, hand-drawn map from 50 years ago to solve a crime. And here's the hidden flaw. On the right, what if that map has missing streets, or roads that don't exist anymore, or it's just plain wrong? Well, the AI's performance is completely capped by how good that initial map is. It can't fix it, it can only follow it, for better or worse. So, to get around this, the researchers knew they needed a totally new approach. They needed to turn the AI from a simple map reader into a world-class cartographer. And this is the question that just changes the whole game. Instead of being stuck with some flawed, pre-made map, what if the AI could constantly update and redraw it? What if it could discover the true connections in the data all by itself? And that brings us to the hero of our story, the Graph Learning Convolutional Network, or GLCN. Now, this isn't just some small update. This is a complete redesign. It takes two huge jobs, learning the best possible map and learning from the data on that map, and smashes them together into one single, powerful process. So how does it actually draw its own map? It's all about this brilliant feedback loop. Okay, so it starts with a rough draft of the map. Then it tries to make a prediction based on that map. It checks how well it did, and here's the magic. It uses its own mistakes as feedback to go back and redraw a better, more accurate map. Then it does it all over again. The map gets better, the predictions get better, and the cycle continues. It's a really elegant idea, right? But the big question is, does it actually work? Well, the researchers put the GLCN to the test on a bunch of standard datasets to find out. So let's look at the before picture. When a standard AI uses that old, fixed map, you get a mess. You can see how the different types of data are all jumbled up. The groups are fuzzy and mixed together. The AI is really struggling to see the real patterns here. And now, look at this. This is the aftershot with GLCN. Because it learned its own map as it went along, it's able to organize the data into these tight, clean, super distinct groups. It's a night and day difference. It's just a much, much smarter way of seeing the information. And of course, the numbers tell the exact same story. On this classic benchmark dataset called Cora, the old model gets an accuracy of about 83%. Pretty good. But the GLCN, because it learns its own graph, pushes that all the way up to 85.5%. In this world, that's a really significant jump. But on some tasks, the leap is just massive. Check this out. When they used it to classify images with only a little bit of training data, the GLCN was a staggering 7.8% more accurate than the standard model. A jump that big tells you this isn't just a small improvement, it's a genuine breakthrough. So let's bring it all home. What's the bottom line? It's simple, really.
By learning the connections, the AI becomes fundamentally smarter. This is about way more than just better test scores. It's about giving the AI a whole new capability.
So let's just quickly recap why this is such a game changer. First, adaptability. The AI is finally free from the prison of a bad map. Second, there's this awesome synergy going on. Learning the map makes the predictions better, and better predictions help it draw an even better map. This all leads to a much clearer understanding of the data, and, well, the proof is in the pudding. It just flat out performs better than the old state of the art. And that kind of leaves us with this one final fascinating thought to chew on. We've just seen an AI that can teach itself to see the hidden relationships buried in data. So if it can now draw its own, more truthful maps of information, what invisible structures in science, in medicine, in our own society is it going to help us discover next? The map is no longer fixed, which means the territory of what's possible is now wide open.